If you ever found yourself in a situation where you need a specific USB cable just to realize that you packed the wrong one, boy do I have something for you. In this video, I will show you how to upgrade any old device to a modern USB-C port so you can finally say goodbye to cable clutter once and for all. I will demonstrate this quick mod on a Blue Yeti mic that I picked up from eBay for just $30. But unfortunately, it does not only have a terrible old mini USB connector, it is loose too. Oh, and by the way, this upgrade costs just $1. And no, I'm not kidding. So let's get started. Time to crack this baby open and get our hands dirty. First, let's unscrew the metal stand from the microphone itself. It's held down by these two screws. Nice, the mic is free. I'm wondering if we can pull out the loose USB port already. Let's give it a try. Nope, that didn't work. Okay, let's continue. Under this round piece of rubber, we will find a hidden screw that must be removed. But before doing that, we need to remove all the buttons from the microphone, otherwise we can't get the PCB out. This is a real trial and error process and can be a bit fiddly, so I will try to be as gentle as possible. It's nearly impossible to get it out with just your bare hands. At least with mine it is. My next attempt is to use pliers with a towel wrapped around them to protect the knob from scratching. This is still too slippery and it felt wrong. I was really worried that the pliers might press through the towel and scratch something. Silly me, I forgot again to start a timer for you so you could get a feel how long our journey takes. With some wiggling, I managed to get one of the knobs out. Maybe my hands aren't as useless as I first thought. Whoa. I was able to remove most of the knobs using one of my repair picks. This method worked flawlessly until I reached the tiny mute button. The pick is too big for this one. Maybe I can pry it out using the nearby opening. This tweezer could be a good lever to use. Come on, get out! The stubborn mute button has finally given in and we can continue with our mission. Under this decal there are also two hidden screws. To loosen it, I will use my hot air soldering station, but you could also use a hairdryer to soften the adhesive. Because my fingernails were too thick to get under the decal, I used the thinnest tool I could find. Now we can slightly peel it back to get access to the screws. Remember, the best tools are always the ones you have at hand. You don't need expensive equipment, it can make life easier, but with some creativity and extra time you will also reach your goals. Let's finally remove these screws to get the board out. We should be able now to pull the guts out of the housing. This looks quite nice with a thick metal frame inside. I didn't expect that.
Yeah, there it is.
The metal cage of the mistreated mini USB connector finally gave up. Here you see the outer shell of the mic. It feels really heavy and high quality. I would love to see more devices with rigid metal cases in our plastic-filled world today. These are the leftovers of the USB connector we want to remove. To remove the daughter board, we will take out these screws. The board is connected via this small pin header. I apply gentle pressure from the back of the board and it pops out. I use my beloved Omnifixo third hand for this. The money was really well spent. Nope, I'm not sponsored by them. I bought it with my own money and just love this product. Let's take a look under our trusty microscope so that you can have a better view of what I'm doing here. Please, when you solder, always use a fume extractor. You don't want those nasty fumes in your lungs, believe me. As a second mantra, always use flux. It helps the solder flow and is a must-have tool for your soldering work. Time to fire up the soldering iron. I use leaded solder to lower the melting point of the existing unleaded solder, making it easier to remove it in the next step. Because it contains lead, it's very important to use a fume extractor, as lead can be very harmful to your health. For the removal of the solder, I use solder wick, which acts like a sponge for solder when heated. You could also use a desoldering pump, but I prefer the wick. It's just personal preference. For this operation, we want to transfer as much heat as possible to the wick. That's why I'm using the flat iron tip, which provides better heat transfer. To clean up the remaining residue, I use cotton swab soaked in IPA, also known as 99% isopropyl alcohol. It's the perfect cleaning agent and very versatile. Oops, I thought the leftover bits of the connector fell down, but that wasn't the case. So let's reapply solder to remove it completely. There it is. Okay, now let's get the holes cleaned out like a shelf on Black Friday in the late evening. To check if the holes are really free of any solder, you can poke them. I will do this with my dental picks, which I use for a lot of general repairs. Perfect, now for some final cleaning and the board will be ready for its upgrade. And this is our upgrade, a compact USB-C breakout board that is ready to use. A USB connection usually consists of 4 pins, ground, VCC and 2 data lines, D+ and D-. On the backside we find some small pads where we can solder a resistor. I will explain more about that in a minute. First, let's solder some wires to the microphone board. For this, we will use a multimeter set to continuity mode to find the right solder pads. We will start with the ground connection. For this, we will place one of the multimeter probes on a known ground connection. In this case, I will use the anchor points of the connector, which are usually a common ground. So far, I haven't found any device that doesn't follow this rule. With the other probe, we check each of the solder pads. When we hear a beep, we have found a ground pin. Nice! I love to use these silicon wires because they are super convenient to work with. Let me cut 4 of them to length. The reason I love these silicon wires is because you can easily strip the ends with just your fingernails, requiring very little force to take it off. Beautiful! Let's apply some flux to the solder pad and solder the ground wire to the pad we just identified with our continuity test. Nice, the ground connection is done. It's always a good idea to check if the connection we made is correct. So let's see if we get our beep to confirm it. Yep, everything is fine. Now on to the next ones. Do you see the small traces with the resistors in front? These are the mentioned data lines. The only problem is determining which one is D+ and which is D-. I have a breakout board to test this, but it only works if your old connector is functional, which wasn't the case here. I explained how this works in a previous video, where I modded a PS4 controller to USB-C. I highly recommend watching that video after this one to get more insights. As far as I know, it's not harmful to use trial and error with the data lines. If you swap them, the worst case is that your device won't be recognized. Then you can just swap them back and everything should work as expected. The only connection left is VCC, also known as 5V. Do you see this bigger trace? This must be our VCC pad. Traces that carry power are usually thicker to handle the current that flows through them. So we have successfully identified all the pins needed for our USB-C upgrade. I will quickly solder the wires accordingly. Now to the optional part. As I mentioned earlier, the module is ready to use, but it comes with one requirement. You need a USB-C cable with one end USB-C and the other end USB-A, the normal flat USB connector we all know. When you want to use a USB-C to USB-C cable, we have to solder an additional resistor to the USB-C breakout board. You might wonder why this is necessary. It's because USB-C supports a variety of different voltages and modes. To make this work, both devices need to communicate with each other to determine how much voltage is required, much like a handshake where they negotiate the terms. This allows the computer or charger to provide the appropriate power. But again, this step is only needed if you want to use a USB-C to USB-C cable, otherwise you can skip this part. I will include the link for the needed resistor in the video description. We need a 5.6 kilo-ohm resistor. This marks our device as a legacy USB device and ensures we get the required 5 volt that every old USB device needs. But be warned, these resistors are very tiny. Here you can see a toothpick right beside it for scale. Here you see the backside of the USB-C breakout board, with the solder pads where the mentioned resistor needs to be placed. Time to carefully free the tiny resistor from the strip using a pointy tweezer. The soldering can be a bit fiddly, but with some flux and a steady hand it's definitely accomplishable. Let's push the resistor to one side to align it properly. Now a bit of cleanup and we should be done. Back to the microphone board. You can see the bottom side of the wires we soldered earlier. The USB-C breakout board will be seated on top of this area, so we should try to flatten it as much as possible. Let's attempt to remove as much solder as we can with our side cutter. To isolate these pins, I will cut a strip of tape and place it over this area. This should help prevent any shorts. Now we will solder the wires exactly as we planned earlier to the USB-C breakout board. Remember, if you are not sure about your D+ and D- connections, it's okay to switch them. Nothing bad will happen, but the device might not work right. If that happens, just switch them back and it should work. That was a lot of information so far. Let's take a short break and watch the cute cats play. Much better, let's keep going. To attach the USB-C board, I will use hot glue. It's not the prettiest way, but it's easy to use. You can also remove it easily with isopropyl alcohol if you have to. Hot glue is good for positioning too, because you can heat it again to move the board if the alignment wasn't exactly right. To see if it fits with the case, we need to reconnect the daughter board to the main board. It doesn't fit right on the frame because the hot glue makes the end thicker. I will fix that by removing the glue in this particular area. I simply move the glue with my tweezers. That looks better. Let's put the screws back in. Time to slide it into the metal case to check how it lines up with the previous USB connector opening. The USB-C connector is wider than the mini USB connector from before, so we need to file it down for a nice and clean fit. I will use a set of small files I bought at a hardware store. Don't file too much down, it's easier to remove material than to fix a hole that is too big. It might be a good idea to check if our microphone actually works. Let's connect it with a standard USB-A to USB-C cable and see if it turns on. The device I connected is a USB meter, which measures the current and voltage in a USB connection. This helps identify power issues when troubleshooting, making it easier to find and fix problems. Let's connect the microphone using the USB-A to USB-C cable. You can see that even before plugging it in, it shows 5 volts. This is because before USB-C, USB connections only use 5 volt. Nice! We see a red light, which means the mic has power. Now let's try the USB-C to USB-C cable. It should work because we soldered the resistor in place, which tells it to run on 5 volts. Let's see. For this, I have to plug the USB meter directly into a USB-C output, otherwise it won't work. As you can see, the meter is dark, because there hasn't been any negotiation yet. This only happens after we plug in our microphone. The resistor should then tell it to output our desired 5 volt. This isn't right. And no, I haven't faked this situation. The behavior you're seeing now is what would happen if you skipped the resistor part. Your device wouldn't receive any power and therefore wouldn't work. I think I messed something up during the resistor soldering. Let's take a closer look. I will remove the hot glue and use the mentioned isopropyl alcohol to do this more efficiently. Let's measure if the resistance is really 5.6 kilo ohm as needed. Okay, let's see. Looks like I used a 56 kilo ohm resistor instead of the needed 5.6 kilo ohm. That's why it's always good practice to check your work right away to make sure everything is fine. So let's do the same thing again, but this time with the correct 5.6 kilo ohm resistor. Now, the lesson we have learned, always check your work right away. Let's see what value we get now. Perfect. Let's go on. Instead of using the black tape from before, I will use double-sided tape to secure it. The adhesive on the other tape wasn't that strong after using the hot glue, so experimenting is sometimes key. It needs a tiny bit more filing to fit. A short burst of hot air to soften the hot glue, and we can align it completely. This looks better than I expected, to be honest. The moment of truth. Will the resistor work and let us use both types of cables? Let's find out. Perfect, the USB meter shows 5 volt and the red light glows like the Terminator's eye. Here we see again the beauty of USB-C. It doesn't matter which way around we put the cable inside, it will always work. Just to show that both cable types work, let's switch to the legacy USB-A to USB-C cable. It works fine with that one too. Perfect! Time to put it all back together and try out if the microphone works on my Mac. Shall we? That looks good. It took me less than 2 hours with all the detours. Not bad, but of course it took some time, so keep that in mind when you want to upgrade your devices.
Hello, it's your captain speaking.
You could have known all along that the microphone was working, because I used it for the voiceovers in this video. Gotcha! By the way, this is the mentioned PS4 controller. I highly recommend watching this video for even more insights and tricks on doing this mod. And as always, happy tinkering!